Now this is question number 52, DS6, paper 2. Now in this question we have to find the values of x that satisfy this equation. The values of x for which cot inverse x equals to minus cos inverse x. Now to solve this inverse trigonometric equation and involving this greatest integer sign, we'll draw graph of cot inverse x greatest integer of cot inverse x, and greatest integer of cos inverse x, greatest integer of cot inverse x and greatest integer of cos inverse x. So to draw graph of greatest integer of fx, we plot fx and then we draw horizontal lines and take the greatest integer value. See, it's like this. Let's discuss here. We draw graph of cos inverse x. This is graph of cos inverse x. We draw horizontal lines at integral values. So this is y equal to 0 line, y equals to 1 line, and y equals to 2 line, and there is no need to no point going beyond this. There will be a y equal to 3 line also, because pi is 3.14, so y equal to 3 line. There is no need to go further because we have to find the solution set only for x greater than equal to 0. So we have to be just in the right half. So we mark points of intersection with the horizontal lines, mark points of intersection between cos inverse x and horizontal lines. So this is the point of intersection with, this is with y equal to 0, this is with y equal to 1, this is with y equal to 2, and then we'll have y equal to 3 also. Now between, if you just see this part of the graph, if we apply greatest integer over it, then these values will become 0, because these values are between 0 and 1. If you take greatest integer over these values, they'll become 0. So basically we have to punch graph, map graph, take projection of graph on horizontal line below the graph. Similarly in this part lies between 1 and 2, and if you take greatest integer of this part, it becomes 1, right? All these values, they are like 1, 1.1, 1.2, 1.3, goes on like this. If you take greatest integer, all will become 1. So this is the graph of cos inverse x, greatest integer of cos inverse x in right half. And similarly we'll draw graph of greatest integer of cot inverse x. We draw cot inverse x, we draw y equal to 0 line, y equal to 1 line, y equals to 2 line. Right, and then we'll have y equal to 3 line also. That there's no need to take. Now mark points of intersection. No point of intersection with y equal to 0. This is the point of intersection with y equal to 1, y equals to 2, and with y equal to 3 also there will be a point of intersection. Now you can see between this part. So from this cot 1 to infinity, this cot inverse x lies between 0 and 1, and if you take greatest integer over it, it will become 0. So for all greatest integer of all these cot inverse values is 0. Similarly between, see this section, if you apply greatest integer over it, it becomes 1. These are values between 1 and 2, so taking greatest integer means it becomes 1. So this is the graph of greatest integer of cot inverse x in right half. Now we have to find where cot inverse x equal to minus of cos inverse x. If you look at the graph, you can see that both these graphs, none of the graphs can take negative values. This is 0, non-negative, 0 or positive. This is also 0 or positive. So it means it is not possible that one is negative of other. So the only values that can satisfy this inverse equation would be those values for which left hand side equal to 0 and right hand side equal to 0, because this is positive and this is positive. Positive equal to negative is not possible. Yes, 0 equal to 0 is possible. So we have to find the values where cot inverse x, greatest integer of cot inverse x is 0, at the same time those values where this is also 0. Now we can see where is cos inverse x 0. Cos inverse x 0 is possible when for these values cos 1 to 1. and cot inverse x, greatest integer of cot inverse x is 0 from cot 1 to infinity. From cot 1 to infinity. Now we have to take intersection of these values. Now before we take intersection of these values, we can see cos 1 is less than cot 1. To see this, you can just look at like this. Cot 1 is cos 1 by sin 1. Cos 1 by sin 1. Now it has to be greater than cos 1, because you're dividing cos 1 by a number that is less than 1. You know sin 1 is less than 1. Maximum value of sin is 1, so sin 1 has to be less than 1. So if you're dividing cos 1 by a number that is less than 1, this will become more than cos 1. So that's how cot 1 is more than cos 1. So if you plot these solutions, one solution is from cos 1 to 1 and other is from cot 1 to infinity. And cot 1 is less than 1. If you see the graph of cot, you can easily see that. This is pi by 4 value when the cot is 1, and this is 1 value, and this is cot 1 value. So cot 1 will be below 1, right? So the common one solution is from cos 1 to 1, other solution is from cot 1 to infinity. So common solution is cot 1 to 1. So answer is cot 1 to 1.